Hey,
How's it going?
pretty good. Sorry about that.
That's all right.
Was a- Kept trying to said I'd get the invite, but it wouldn't let me do anything with it.
Oh, really?
So yeah, but figured it out
Oh,
again.
good. Yeah. All right.
Every
So I was,
every time.
yeah. So I wasn't sure if you're gonna be able to tonight. So I went ahead and
What was that? Sorry.
when you texted me back, I was just doing the quiz on my own the first time, and
Oh,
so
nice.
we should be good to go.
Sweet. Thanks for doing that.
Yeah. So I know which ones are
Right.
right now.
Oh, you already submitted it too.
Yeah, because
Oh man.
I had to in order to start the second one. So
Uh huh. How'd you do on the first one?
I got a 73.9.
Ooh, I'll take it.
Yeah. So
Just kidding. Sweet. Let me get it open.
missed 4 questions.
There you go. It's only 21. Cool.
Yeah.
Sweet.
All right.
Okay.
We just jump right into it.
Yeah. Question 3. Which hypothesis involves equality? Would that be the true hypothesis?
It's actually the null hypothesis.
Null hypothesis?
Mm-hmm.
Okay. Sounds good. So question 4.
Remember that.
Remember that? Oh, go ahead.
I said remember that the p-value is the probability of obtaining a sample statistic at least as extreme as one that was actually observed. When computing the p-value, which hypothesis do you assume to be true? And that one is also the null hypothesis.
Okay. So you always assume the null hypothesis is true.
Yep.
Okay. Got it. Okay. Question 5. Which of the following represents the alternative hypothesis for a two-tailed test? Now, what is a two-tailed test?
So let me see here. Okay, let's see. Okay, so the p-value is determined using the alternative hypothesis. If the alternative hypothesis is two-sided, so that means if the alternative hypothesis involves it's like the equal marks with a line through it, then the
Okay.
p-value is the area in the tails further than plus or minus z. That is, it is the area to the left of z and plus the area to the right of z.
Okay.
So if it's the mean, like can't be equal to 10 or whatever, then that's the two-tailed test. And like on
Okay. So
the applet, you'd highlight the two ends, the one end on like the far right of the z-score, and then the far left of the z-score. It's on.
okay.
Does that kind of make sense?
I think so. I think that'll make more sense when we have like calculations.
Yeah.
So it's the mean is not equal to 10.
Yeah, that's the correct answer.
Cool. Thank you for explaining that one.
Yeah, you're welcome. Which of the following represents the alternative hypothesis for a left-tailed test? I believe that one is the mean is less than 10, I'm pretty sure.
Okay, because it's to the left, right?
Mm-hmm. Yeah. The shaded part of the applet would be left of the z-score. So
Okay. So it would be less. That makes sense. So then the right-tailed test would be mean is, oh, actually, the mean is greater than 10.
yep.
Okay.
All right. Remember that we determine the outcome of a hypothesis test by comparing the p-value to the level of significance, or I forget what that symbol means. To use this information to answer the next two questions. Which relationship would result in failing to reject the null hypothesis? So in order to reject a null hypothesis, so to reject a null hypothesis, you have to have a small p-value. Or this is failing to reject. So on the lesson 9, it's got that little chart. It says large p-value. It's the fail to reject the null hypothesis. So it'd be p-value has to be greater than that symbol. The
Is
O.
greater than. Okay. Okay, so the p-value is greater than the level of significance.
Yep.
And what did we say the p-value was? It is.
Well, it's just asking. It says,
Probability. Okay.
yeah.
Okay. Cool. Good stuff. Okay. Which relationship would result in rejecting the null hypothesis? That be p-value is less than point of reference.
Yep.
Cool.
Okay. The insurance company is reviewing its current policy rates. When originally setting the rates, they believed that the average claim amount was $1,500. They're concerned that the true mean is actually higher than this. Use this information for the next two questions. Which of the following would be the appropriate alternative hypothesis? So alternative hypothesis.
Would it be the average claim is amount is greater than 1,500?
Yes. Actually. Because you
Or
are
is it?
because I think that they're concerned that the true mean is actually higher than 1,500. So the alternative hypothesis, the average claim amount is greater. Yeah, that's right.
That's the right one?
Uh-huh.
Okay. Cool. Because that one, we can say, use that same. Oh, sorry. Let me throw a pacifier in. Hey. 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 Sorry about that.
Oh, it's all good.
She's getting to the stage where she just wants someone to talk to her.
Yeah.
But that one. Yeah, because that goes along with that p-value, right? If the p-value is alternative, so I guess we talked about rejected. Never mind. Don't know where I was going with that one.
Oh, it's all good.
Okay, number 11. Which of the following would be the appropriate null hypothesis?
So it's kind of like one of the questions we answered earlier about the null and hypothesis.
So null is the true answer, right? True statement.
I believe so.
So would you say the average claim amount is equal to 1,500?
Oh wait, the null is the one like in question. In question 5, it's like the two-tailed test.
Uh-huh.
So it would be that it would be the average claim amount is not equal to 1,500.
Is not equal to. Okay.
So the insurance company randomly selects n equals 40 claims and calculates a sample mean of x equals 1,650. The insurance company assumes the distribution of the sample mean is normal. Is this a good assumption? Is a good assumption since the sample size is large. That's what I said.
Because the sample size.
Kind of a review question there.
Yep. Cool. 13, right?
Yep.
What theorem of law justifies your answer to the previous question? And would that be law of large numbers?
That's what I thought, but it's actually not.
Oh, is it central limit theorem then?
Yeah, I think so.
Oh. Those two get me confused all the time.
I know, me too. How'd you do on the exam?
I got a low B.
Nice.
It'll work.
Yeah, I think I got a high C on it.
Yeah.
But
It was, I felt really confident about it, and then I submitted it, and I was like, oh, dang it.
yeah, me too. Like, I don't feel like there's very many that were that hard for me to answer, but
Yeah, exactly. Especially when it said you need 4 or you can take 4 hours on it. And I was
yeah,
like, oh, I finished it within the hour, and I was like, oh, man, I feel good about that one.
yeah, same.
Should have taken some more time.
Yeah, yeah, me too. So 14, which of the following is the test statistic as defined in this lesson? I said it as the X with the line over it. That's what I thought I found, but it says it's wrong. So I'm going to try and find the right.
Does it even mention Z or S?
Okay.
I don't see Z or S in any of the.
I think it's either got to be X or N. I guess it's not X. So
I'd go with N.
yeah. Oh yeah, that makes sense.
Sweet.
Oh, wait. So I'm looking in the reading, and it says where Z is the test statistic, X is the sample mean, that you think is the population mean, O is the standard deviation, and N is the sample size. It's in 4.2.
Oh, as defined in this lesson, not in this problem. Whoops.
Yeah. So Z is,
Yeah, so Z is the one.
yeah.
Cool. Thanks for looking that one up.
Yeah, no problem. So then the historical mean of sales receipts at a grocery store is $150 with standard deviation of $40. The store manager suspects that the average has decreased. She sets up a hypothesis test with the hypothesis is equal to 150 or less than 150. She'll use a level of significance of 0.05. She then takes a simple random sample of 36 sales receipts from her store and computes X equals $144. Use this information. What is the Z-score associated with this test?
Was there a new formula given in this lesson?
Huh. No, I don't think so. I still use the same Z-score formula, where it's the X thing minus the mean divided by you use the level of significance divided by the square root of N, which is 36.
Oh, okay. So your standard deviation is at 0.05?
Yeah.
Oh, okay, gotcha. So did you get negative? That doesn't make sense.
Well, what'd you get?
Negative 720.
Oh, nope, that's not what I got. So you do Z equals 144 minus 150 divided by 0.05 divided by the square root of 36.
Yep. Maybe I did my operations wrong. Let me. What answer did you get?
I got negative 0.9.
0.9?
Yeah, negative 0.9.
What did I do? Huh. Okay. I don't know why I'm getting a different answer.
Okay.
Because you did 144 minus 150, right?
Yep. That gets you negative 6.
Negative 6, yeah.
Then you do, so the square root of 36 is 6. So
Yeah.
0.05 divided by 6. And you get 0.008.
Yep.
6 divided by 0.008. Oh, what the? 750?
Okay. So I'm not crazy?
Oh, I know what I did wrong. Okay. So you actually keep the standard deviation of 40.
Oh, there's a different standard deviation.
Yeah. So it's got to be
Wow.
40 divided by 6
Okay.
equals
Okay.
6.666. Okay. And negative 6 divided by 6.666.
Okay. And that's how you got the negative 0.9?
That's how you get the negative 0.9, yeah.
Okay. Cool.
Sorry about that. I
No, all good.
was looking back to my notes, and I was like, wait, because I did it the wrong way the first time, and then did it the right way the second time. So
Yeah. So do we end up using that 0.05 or no?
let's see. I don't think so, actually.
Okay. At least not in that problem.
Yeah, not in this problem.
Okay, cool. Hey. Okay. It's okay. It's not that bad. Hey, give me 1 second. Let me see if I can hand her off.
Okay, you're good.
You're all right. Is that possible? Okay. Number 16.
Yep.
What is the p-value associated with the z-score from the previous question?
Yes. So negative 0.9 is our z-score, so then we just plug it into the applet to get our
Oh,
p-value.
okay. It was negative 0.9, right?
Yep.
And then we're going for, is it the numbers below it? Or
Yes. Because she's afraid that it's less. The mean is less.
yep. So it's 0.184.
Yep, that's correct.
Okay.
Then what inference would you make about the null hypothesis for this problem? So we look back.
So what do you think?
We have a pretty large p-value. And so if the p-value is large, then we fail to reject the.
So what's considered a large p-value?
I was just trying to figure out.
Oh, okay.
So it says if the z-score is small, then there'll be a lot of area in the tails beyond z. In other words, the p-value will be large. These two possibilities are illustrated for a two-tailed test in the figure below. Similar results hold for a one-tailed test. Okay. And then it says, in case of the body temperatures, it's talking about an example in the reading. A large z-score led to small p-value, the area in the tails. We observed a value for x that was very far from the mean. Okay, so yeah. So if the z-score is small, then your p-value is going to be large. Therefore, you fail to reject the null hypothesis. But if you've got a large z-score, then your p-value is going to be small, so you reject it.
So then this one's considered failed to reject then?
Yeah.
Okay. Cool. Question 18, what is your conclusion for this problem?
So I actually guessed on that one, and I got it right because I couldn't find anywhere in the reading.
Okay. Did you say sufficient evidence?
I said we have insufficient evidence that the true population mean is less than 150.
Okay.
Which I'm not sure how I came to that conclusion.
Well, because we have like what 18% that's below 150,
That's true.
or I guess we're not below 150, but below 144.
Yeah.
So it's kind of like in between. It's not a high number, but it's not a low number.
Yeah. I guess that makes sense.
That's kind of how I would look at it. I think I don't know though.
Yeah.
Some of the stuff I think they make up on the fly.
Yeah, it's definitely different. Different type of math.
Yep. Cool.
All right. So
Question 19. There are two types of errors that can be made when performing a hypothesis test. Which one involves rejecting the null hypothesis when the null hypothesis is true?
the nifty little table, 4.5.
Which one? What?
4.5 in the reading.
4.5. Let me scroll down to it. Okay. And the question was involved rejecting the null when the null hypothesis is true.
Yeah, so if the null hypothesis is true and if they reject it, it's a type 1 error.
Okay, yep. Nice. Where did my quiz go?
Then a researcher decided that instead of using a level of significance of 0.05, he would use a level of significance of 0.01. Which of the following will be true? So
His experiment will be more significant or scientifically valid? No.
See, I was able to figure this one out. Let me
Okay.
see here. Okay, so see, so if we go back to one of the other, the p-value says that. So on question 17 says, what difference would you make about the null hypothesis for this problem? Said it'd be a fail to reject the null hypothesis. That's with the problem being calculated with 0.05.
Uh-huh.
You'd fail to reject the null hypothesis. All right. And so then if you change it to 0.01, that would make the null hypothesis false. So it'd increase the chances of a type 2 error, right? Pretty sure that's how I figured it out, because that is the right answer.
Okay. So probability of type 2 error will increase?
Yeah.
Okay. I'll have to look more up on that one.
Yeah. Oh, okay. I just found it.
Oh, yeah.
Yes, this is type 1 error is committed when we reject a true null hypothesis. Another problem that can arise is to fail to reject a false null hypothesis. We do not want to commit type 1 errors, so why not choose a very small value for, I can't remember what that symbol's for.
Point of something.
Yeah. If we choose that point of something to be small, to be so small that we rarely commit a type 1 error, what would happen to the probability of committing a type 2 error? Think about it. So it would go up. Okay, so because the number got smaller, the probability of committing a type 2 error went up.
Okay, because we were a type 1 error.
Yeah.
Okay. The type 2 error was when you fail to reject and it is false.
Yeah.
Okay. So if you're not, that makes sense because you only have, it's like 50-50 chance, right?
Yeah.
So if you take one error away, your only other option is to make the second error.
Uh-huh. Very
Or
true.
you get the correct decision. Okay. Makes sense.
Then I got 21 wrong. I told you to calculate the probability. So compute the probability of committing a type 1 error if the one thing is 0.05.
Uh-huh.
So now I'm trying to figure that out. In other words, the level of significance is the probability of committing a type 1 error. Oh. So if the level of significance is 0.05, compute the probability of committing a type 1 error. It'd just be 0.05, right?
Is that what it means?
Yeah, it says the level of significance is the probability of committing a type 1 error.
Really?
Yeah, and 4.5, the second paragraph.
Oh, so that makes sense why if that one goes down, the other goes up.
Yeah.
That makes a lot more sense. Okay.
Yeah, so I guess the answer for 21 is 0.05. Because level of significance,
Awesome.
the probability of committing that type of error.
So then would that mean to wait, hang on. Yeah, so type 2 error is 0.95 then? Can it be said that way or no?
You mean for 21?
Yeah, I mean, well, in like a different way of looking at it, if you needed the probability of a type 2 error,
I'm not sure what the probability of a type 2 error would be.
it would go back and forth. So, well, did we answer all the ones that you had questions about?
Yeah, we did.
Those four? Okay. Let me go ahead and submit mine. Did you already submit yours?
Not yet, but
Okay, let me submit mine and see what we do. Oh. Okay, number 11 I got wrong.
number 11.
Yep, just number 11. So I wonder if I clicked something wrong. Which one did you click on that one?
The average claim amount is not equal to 1,500.
Yeah, that one's wrong. Is that what you got last time?
Yeah. Oh, that.
And I was right.
Oh man, that's what I said last time, and it was wrong.
Oh,
So that one was my bad. I misread that one.
all good. So would that one be? That's a null.
Oh, the average claim amount is greater than 1,500. I think is the right answer.
Greater than. Okay.
I think. They're concerned that the true mean is actually higher than this, so the null hypothesis would have to be the average claim amount is greater than 1,500. Wait, what? No. Maybe it's supposed to be equal to. I'm going to try it as equal to. I think that's what it is.
Let me. Yeah, I think it is. Average claim amount is equal to 1,500
Yeah.
because the null hypothesis is your standard status quo. It's what you think it is.
Yeah. So that's the correct answer.
Nice.
So.
Cool.
All right.
We got those all figured out.
Yeah, me too.
Awesome. Hey man, thanks for being super flexible on meeting time and such.
Yeah. Thank you.
I
Same to
appreciate
you.
it.
I'm not working as much as you are, but I'm working more than some other people, I think. So.
Yeah. It's tough working in school, but hey, we'll get through it.
That's right. I guess I'll see you next Tuesday.
Sounds good. We'll see you.
All right. Take care.